Okay, so for today, we're going to solve some examples about flow nets. So let's take this example for first example. So allow me to read the problem. A flow net for flow around a single row of sheet piles in a permeable layer is shown in the figure. Given that Kx is equal to Kz is equal to K, which is equal as well to 5 times 10 to negative 3 centimeters per second. Determine how high above the ground surface the water will rise if piezometers are placed at points A and B, and then the total rate of seepage through the permeable layer per unit length, and the approximate average hydraulic gradient at C. Okay, so first of all, we need to determine how many equipotential drops do we have. Okay, so tingin tayo dito sa figure. So how many equipotential or how many areas are cut by the equipotential line? So we have one here, 2, 3, 4, 5, and 6. So we have 6 areas, okay, for the equipotential drop. So every time that the water will soak and pass through each area, okay, nagkakaroon po tayo ng head loss. Okay? So the head loss, the total head loss is actually this one, your H. Okay, that's from the upstream to the downstream. So the head loss, okay, when the water passes through the upstream going to the downstream, every time na nagko-cross siya ng equipotential drop area, nababawasan yung kanyang head. Okay, and the number of each uh, each head, okay, on that area is actually just equal to the total head loss divided by the number of the equipotential drop. Okay, so for example, in here, let's say 5.6 minus 2.2. Okay, so that's 5.6 minus 2.2. That is already your head loss. Okay, and in order for us to determine kung ilang meters or centimeters yung head loss per equipotential drop, i-divide lang natin yung result by the number of equipotential drop. Okay, so yun yung naman yung gagawin. Okay, so in this case, we have 6 potential drops. So let's try to calculate number 1. How high above the ground surface the water will rise if piezometers are placed at points A and B. So if I'm going to place a piezometer at A, in here, sa point A, dyan daw natin nalagay yung piezometer natin. So natin yan. How high will the water rise daw? Okay? So gawin natin is, computin muna natin kung ano yung magiging delta H natin. Okay? Or the change in the head each time the water passes through the equipotential area. Okay? So here's our first solution. We just write it here. Okay, so we have to determine that change in the head every time the water is traveling through each equipotential drop. Okay, so the delta H now is equal to just the H upstream minus the H downstream. Okay, divided by the total number of equipotential drop. And that is equal now to 5.6. Okay, 5.6 kasi yung upstream na elevation ng tubig natin, guys. We have 5.6, this one, that's the upstream, and then we have 2.2 naman sa baba. Okay, and then we have 6 equipotential drop. Okay, so we now have 5.6 minus 2.2 all over 6. Okay. And that is now equal to 0.567 meters. Ayan. So that is your delta H. Okay, so every time that the water passes through the equipotential area, the water elevation in the piezometer, if you're going to place a piezometer in each equipotential area, bumababa yung tubig ng 0.567. Okay, until ma-reach niya yung downstream elevation. Okay, so at point A, determine na natin at point A, alamin na natin yung magiging water elevation. Okay, if we're going to put a piezometer there. Okay, so ilang equipotential area ang dadaanan ng ating water. Okay, as you can see in here, this is actually the first potential area. Okay, so isang equipotential area lang yung dadaanan niya papunta ng A. Okay, because this is actually your first area kasi talaga. Ito. Okay, this is your first equipotential area. That, okay? So, yan yung magkakaroon ng first equipotential na drop. Okay? So, balik tayo doon. So, at point A, that would be the H upstream minus delta H times yung number ng equipotential drop passing. Okay, sabihin na natin ang ND passing. Okay, so that is 5.6 minus 0.567. Ilang potential area yon? There's only one. Okay, so that is now equal to 5.033 meters above the ground surface. Take note, this is above the ground surface, okay? Ayan. Yan. So, this is now your answer. Okay? That is your answer. Okay, so the water at point A will be 5.033 meters in elevation. How about at point B naman? How about at point B? Okay, because the first question asked the elevation of water placed at points A and B. Okay, so saan ba ang point B natin? Okay, so this is your point B. Okay, so count natin yung area na pwedeng daanan. Okay, so this is 1, 2, 3, 4, and then we have 5. Because dito sa area na to, dun nandito yung ating point P. Okay? So, it's here. Now, how are we going to, let's proceed with calculating the elevation, okay, of the water at that point. Okay. So, similar lang, that would be 5.6 minus 0.567 multiplied by how many areas are we going to pass through papuntang kay B? That is 5. Okay. So, your answer now is 2.765 meters above the ground. Ayan. Okay. So that is your those are your answers for item number 1. How about sa item number 2? What was the question? Okay. So balikan natin na item number 2. So the total rate of seepage naman daw through the permeable layer per unit length. So how are we going to determine the total seepage? Okay. From the problem. Okay. So, in order for us to determine, guys, the number of the seepage, okay, gamitin natin yung formula na ito. Okay. So, since ganyan yan, Q now is equal to, wait lang. Is equal to 2.38 K multiplied by H1 minus H2 all over the number of potential drops. Okay? So that formula is actually um, taken, okay, from the previous discussion that we have. That's 2.38 kh all over nd. Okay, and yung h natin doon, that is actually the head. Okay, the head difference between the upstream and the downstream level. Okay, so let's now calculate or substitute the values. We have 2.38 multiplied by, what is our given k? Ang given k natin is 5 times 10 to the negative 3. Okay? So we have 5 times 10 to the negative 3. What is our h1 and h2? That is 5.6 minus 2.2 all over how many areas are we going to pass through papunta ka sa downstream level? So, bilangin natin 1, 2, 3, 4, 5, and 6. Kasi the 6 contains already this one. Okay, this specific area in here. And this is the last area that we're going to pass through. Okay? So, lagyan natin dito 6. Okay. So, what is now our Q? Our Q now is 6.74 times 10 to the negative 5 m cubed per second per meter. Okay, so that is your final answer. There. Okay. Okay, so let's proceed to question number 3. Okay. So, tinatanong din sa atin yung approximate average hydraulic gradient at C. Okay. Oops. Okay, saan ba yung si C? Okay, this is C. This is point C in here. So, tinatanong sa atin kung ano yung average na hydraulic gradient. Okay, so the hydraulic gradient is actually your change in, that is the head loss all over the length of the flow, diba? Okay, so what is our head loss in here? Okay, so we'll only be considering, take note guys, this is the head loss ha, head loss. Okay, so kung meron tayong point D hanggang E, and then nakalagay dyan kasi is our average distance between D and E. Take note, yung C is lies in this area. Okay? The second equipotential line. Pero yung head loss natin guys, that will just be equal to the unit head loss. Okay? So, what is our head loss kanina? Upstream minus downstream, and then divided by the number of equipotential area. So, that is yung head loss natin or the change in the head is 0.567. Okay, so we're going to use this 0.567 to estimate the hydraulic gradient in here. Okay, we're not going to multiply it with the number of channel or the number of area. Kasi this is already the second area, di ba? Yung C natin lies on the second area. Pero hydraulic gradient kasi yung tinatanong. It's not the number of, it's not the decrease in the water elevation. Okay? So, ang tinatanong dito is yung hydraulic gradient. Okay. So, in this case, gawin natin is, yung I natin will now be equal to the head loss all over average length of flow. There. And this is now equal to the delta H all over the delta L. Okay? Or sabihin na lang natin delta L yung average length of flow. Pero binigay naman na guys yung average length of flow natin, di ba? That's 4.1 meters. Okay? So nakalagay na dyan. This is our average flow kasi it is presumed that the flow of water is in this direction. Pag ganyan. Okay? So, that is just the approximate. Okay? So, 4.1 yon. So, what will be our delta H? That is 0.567 meters all over 4.1 meters. And this is now your hydraulic gradient. Okay? That's 0.138. Okay? So, that is your hydraulic gradient. Okay. So that is our example for the flow net. And take note, yung flow net naman natin, kung ano yung problem dito, that will be the problem as well on your activity and quizzes. Kung meron mang flow net doon. Okay? So we're just going to use this standard example na lang. Okay? Including yung values niya. Okay? Including the value. Ibahin ko na lang yung coefficient of permeability later on. Okay? So, yun lang naman, guys. So, that is our example for the flow net. Okay? Flow net. Okay. So, let's proceed to the second example. Okay. So, ito na yung second example natin, the dam. Okay? So, we have this figure. So, this is just similar to the figure which was stipulated in the LMS, no? So, ito yung magiging basis natin na figure lagi. Pag ganitong dams ang mga binibigay. Okay. So, tandaan natin what was our main goal. That is to calculate for the L and then calculate for the seepage. Now, if you can recall, guys, try natin i-recall yung ating seepage through the dam. Wait lang. Let me just check yung ating formula. Okay. So, we do have kasi yung formula for the seepage of the dam. Okay, the earth dam. Okay. So, in the seepage formula for the earth dam, sabi doon, this is step by steps, guys. Sa LMS siya, we have to determine yung ating L. Okay? So, the first thing that you're going to do, okay, given this certain condition, okay? Sulat ko lang muna yung formula before ko pasahin yung problem. So, your L is given by the formula D over cosine alpha. Okay, minus the square root of D squared all over cosine squared alpha minus H squared all over sine squared alpha. Okay? And after getting the L, pwede na natin ma-determine yung value ng ating seepage. Okay? So, the seepage, as you can see in the LMS, the seepage formula is actually given by K tangent of, or should I say KL, yan, tangent of alpha, then sine alpha. Okay. So, our main goal is to determine the seepage. So, let us read the problem. Okay? So, refer to the earth dam shown given that beta equals 45 degrees, alpha is 30 degrees, B is 10 feet, and H is 20 feet. Height of the dam is 25 feet. And K equals 2 times 10 to the negative 4 feet per minute. Calculate the seepage rate Q in cubic feet per day per feet of the length. Okay, so isulat ko lang yung mga given dun sa problem doon sa ating figure. Okay, para mas madali tayo mag-compute. Okay, so once again, sinasabi ko na, guys, na kailangan nating basic trigo. Okay, we need a basic trigo natin dito. Okay, mga Sokatowa, mga ganyan. Okay, so I hope you can still remember. So, ito, lagay ko lang dito. Yung beta mo is 45 degrees. Yung alpha mo, that is actually equal to 30 degrees. Ayan, yung alpha mo. And then, yung B mo is 10 meters. Okay, so yung B mo is 10 meters, this one. And then, yung age or the height of the water is 20 feet. So, this one is 20 feet. Okay, and then we have height of the dam. Okay, the height of the dam is itong height na to. Ito. Okay, consider this height, guys. Okay, this one until dun sa base. Ayan. So, that one. The height of the dam is 25 feet. Okay, so that's 25 feet daw yung dam. Okay, so, wait lang. So, natin dito. Ayan. So, from here to here, that's 25 feet. Okay? So, ayun. Then, let's now try to calculate the seepage rate. Okay? First thing to determine is kung ano yung D. Okay? In order for us to get the D and to get the L later on, we have to compute or we need to take yung sum ng distance from this point to that point. Okay? So, yan yung magiging distance natin. So, that's the D. And the D component is actually, or the distance, okay, from this point A prime to the D, okay, can be calculated using basic trigonometry. Okay. So, first, gawin muna natin as dun sa mga steps. The first step is we have to determine yung delta. Okay? So, how are we going to determine the delta? Okay? Ito guys, yung delta is kasama siya dun sa summary. Okay? Sa summary nung step by step. First, we need to calculate the delta and the 0.3 delta. Okay? So, lagay ko dito, calculate delta. Okay. So, your delta now, okay, is equal to, anong delta natin? Where's the delta here? Okay. So, here's your delta. So, your delta is from this point or this triangle. Okay. So, if we do have 45 degrees in here, okay. So, if we do have 45 degrees there, okay. Diba guys, yung height ng water, yung tinutukoy na dito. So, this is actually 20 feet. Okay. So, how are we going to get the delta? Okay. So, your delta is actually given by, let's use tangent. Okay. So, tangent of delta is equal to 20 feet. 20 feet all over a joke lang guys, hindi pala, that's tangent of 45, not the delta. Okay. This is tangent of 45 is equal to, wait, sulat ko nga na maayos, sulat ko na siya maayos. Okay, so tangent of 45 degrees is actually equal to adjacent, which is delta. Okay, tangent, opposite, wrong. It's TOA pala. So, it should be opposite. So, that's 20 all over delta. Okay? So, in this case, your delta now is equal to 20 all over tangent ng 45. Ayan. So, hindi ko muna siya i-compute, guys. Hindi ko muna siya i-compute. Okay? Okay. So, next thing, after we determine ang delta, let's now get the 0.3 delta. Okay? Okay. So, what is tangent of 45, guys? I think tangent of 45 is actually 1. Okay? So, your delta now is equal to 20 over tangent 45. That's just 20 as well. So, 0.3 delta is 0.3 multiplied by 20. Okay, so what's now your 0.3 delta? It's actually 6 feet. Okay, so 6 feet siya. Ayan. Ayan. So, this is now your kalimutan ko to, feet. Ayan. So, those are now your delta and the 0.3 delta. Okay. Next, pag meron na tayong delta, according to sa LMS, sabi, we need to calculate daw the D. Okay, that's the second step. So how are we going to calculate the D? Well, let's try to use a basic let's try to use basic mathematics, or in the context of trigonometry. Okay. So, burahin ko lang to, guys. Okay, I hope you were able to um, remember. Okay, so this is 45 and this is 30 degrees. Ayan. So, in order for us to get the D, we just need to actually divide the section into parts para makuha natin yung value ng D. Okay, so in this case, I'm going to divide it into something like this. Okay. Okay. And then to yeah, and then the last part is 0.3 delta, that's somewhere here. Yan. So what will be our D? What will be our D? Ayan. So ito hanggang doon. Okay, so how are we going to get this one? Okay. So try natin yung ating mga equation, or try natin i-derive yung equation natin for that one. Lipat ko lang to dito, guys. Ayan. So, how are we going to get now the D? Okay, as you can see, wala tayong problema dun sa mga nauna. So, your D is just actually equal to, okay, first is itong distance na to. What is the distance here? Okay, applying applying trigo. Okay, what's the distance here? So, the distance there is just actually tangent. Okay, the tangent function then. Okay, so that is tangent and 30, okay, is equal to opposite over adjacent. So adjacent now, so we can say that tangent of 30 degrees is equal to opposite over adjacent. Okay, ayan. Ayan siya. So, pero yung opposite mo, guys, this is actually the height of the dam. Tama ba? So, the height of the dam in there, okay, which was given, is actually 25 feet. So, that should be written, tangent of 30 is equal to 25 all over the adjacent. Okay? So, hindi natin alam kasi kung ano to. Okay, this is your X value. Okay? Or your A value. Okay? So, A now is equal to 25 all over tangent ng 30. Okay? So, your the first input in the D distance is actually equal to 25 all over tangent ng 30. Okay. Plus. Okay, plus. Ano tong distance na to? That is actually equal to the B of the earth dam. Okay, so the given B of the earth dam is actually 10 feet. Okay, so that is plus 10 feet. Okay, next, okay, mag-add tayo. How are we going to get this distance then? Okay, how are we going to get this distance? Okay, in order for you to get that distance, sabihin na lang natin that is X. Okay, X distance. Okay, your X distance is actually equal to, I'll erase na ito, ha. Okay, so your X distance is actually equal to, okay, so meron tayong 0.3 delta dito. This one, we have 0.3 delta here. So, kailangan din nating kunin yon. Okay? So, what we can do is actually use trigonometry again to to solve for the x distance. Okay. So I think this is just equal to 0.3 delta. Okay, ito. So 0.3 delta kasi yan siya. Plus, ano yung kwan natin? Yung magiging kwan natin. Okay. So, magiging working equation natin is plus, okay, the difference between this, the base of this triangle, okay, and then, itong triangle na to. Ayan. So, we need to take the difference between the bases of this big triangle as well as this triangle. Okay? So, how are we going to do that? That is just equal to, okay, 45, we have 45 degrees here, and this is actually the height of the dam. So, that is tangent then, tangent. Okay, so that is 25 all over. Okay, sabihin na tangent at 45 equals, okay, yung big triangle natin, that is opposite, that is 25 all over adjacent. Okay. Or sabihin na lang natin this is, brain ko to. Ayan. So sabihin na natin this is this distance here is your y. Okay, so that is your no na lang. Sabihin na lang natin x1. Okay, x1. So your x1 now is, ayan. So tangent 45, tangent ng 45, tangent nito is equal to opposite all over the adjacent. Okay. So that your x1 distance now, okay, your x1 distance is actually equal to 25 all over tangent ng 45. Okay, so that's 25 all over tangent ng 45 degrees. Okay, minus, okay, because we have to get the base as well of this rectangle or triangle, this one, this triangle in here. Okay, so paano natin kukunin yon? So that is a similar principle that will just be equal to the height of the water, kasi this is already the height of the water, guys, opposite over adjacent. So that is just equal to 20 all over tangent ng 45. Ayan. Okay. So your x distance, okay, or yeah, the x distance now is just equal to 0.3 delta plus 25 all over tangent 45 degrees minus 20 over tangent ng 45 degrees. Okay? So that will be the x value. Okay. So yung x value, baka makalimutan nyo, ito yon. That is your x value. From this point to this point. Okay, so that is your x value. Now, let's summarize. D now is equal to, move ko natin to. Kokopihin kasi natin to actually. Okay. Kopihin na lang natin to, lipat na lang natin siya dito. Okay. Kasi yun lang naman na yung kailangan natin sa equation. Plus 0.3 delta plus 10 ba yun? Yung B natin is 10. Ayun. So 25 tangent ng 30, ayan, plus 10 plus yung 0.3 delta plus itong term na to. Okay? So let's now compute for the D. D now is approximately equal to 64.3 feet. Okay? So once we have already the D, we can solve for the L. Okay? So ayun siya. So we can calculate now for the L. Okay, given yung ating D. Okay. So ito siya. L equals D all over cosine alpha minus the square root of D squared all over cosine squared alpha pala, minus H squared all over sine squared of alpha. Okay? So, what is our L now? Given yung D natin 64.3. Cosine alpha, anong alpha natin? That's 30 degrees. Minus the square root of 64.3 all over cosine 30. Okay, so square na lang natin sila. And then minus 20 all over sine 30 squared. Yan. So your L now is equal to 11.7 feet. Ayan. Okay, proceed tayo sa next question. The next question is yung seepage daw. Okay, seepage at the earth dam. Okay, so that is given by KL tangent alpha sine alpha. Okay, so what is now your Q? That is just direct substitution now times 10 to the negative 4 multiplied by L, that is 11.7, multiplied by tangent ng 30 and then sine ng 30. Yeah. So your Q now is 6.754 times 10 to the negative 4 cubic feet. Okay? Per minute per feet. Ayan. So, pwede natin siya i-convert because they were asking us in terms of cubic feet per day per feet. So that's 0.0, or should I say 0.0, 0.973 rather, cubic feet per day per feet. Okay, so that is now your final answer. So this is your seepage in an earth dam. So ganito guys yung binigay ko dun sa activity ata or sa quiz ninyo. Okay? Kasi mahirap din kasi kung mag-irregular dam pa tayo. Okay? So might as well follow na lang natin yung mga formula and yung steps nila. Yun lang naman yung importante doon. As long as you know the steps and the formula, pwede mo nang laruin yung problem, especially in the dam case, because you have to know your basic trigo. Okay, so you have to apply a basic trigo and medyo analysis kung paano nyo siya i-apply. Okay, so tulad nito, mahirap kasi kunin yung distance ng D. So ayun lang, nag-perform tayo ng sukatowa, mga ganyan. Okay, so that is our lesson for the seepage under flow nets. Okay, hindi ko na i-discuss yung ibang examples kasi that's not part of the quiz and the activity naman. So, i-check nyo na lang yung PDF file because the answers to the problems, okay, dun sa mga non-important formulas natin is nandun naman siya. Okay? So, yun lang for the seepage today. Thank you!